Hello, everybody. My name is Tanilson Dias dos Santos. I'm a doctoral student at the Federal University of the Rio de Janeiro, and today I'm here to present for you work. This work is a joint research with professors Liliana Alcon, Maria Pia Mazzoleni, and institutions Universidade Nacional de La Plata, Federal University of the Rio de Janeiro, and Federal University of Tocantins. The title of this presentation is on subclasses of Helly-B1-EPG graphs. And this work is the relationship, has a relationship with the paper that has been submitted to VirtUMA. VirtUMA that occurred at September 21 to 25 of this year, 2020. This is our table of contents. This is composed by 4 sections. In section 1, we have an introduction. In section 2, we have a brief approach on subclasses of Helly-B1-EPG graphs. In section 3, we present the concluding remarks, and in section 4, we present the references. On grid representations. EPG representations were defined by Golombek et al. 2009. EPG graphs are graphs that have EPG representations. Edge paths intersection on a grid are EPG graphs. Basically, we have a grid that can be visualized as a Cartesian plane and the graph G, and each vertex of the graph G is represented by a path, and this path is drawn on this grid. This is an EPG representation. This way, EPG representations correspond to bijective functions among vertices and paths. Each vertex of the vertex set of the graph G, that is, each vertex that belongs to vertex set, corresponds to the path P of Vi on the grid key, and two vertices Vi and Vj belongs to edge set if and only if the corresponding edge sets of these paths are intersection noempty. We say that a representation is a BK EPG representation when each path of this representation has at most k bands. In other words, each path of this representation has at most k chains of direction. For instance, for the graph C3, in letter B, there is a set of paths where each path has at most 2 bands. Thus, this is a B2 EPG representation. In letter C, we have a set of paths where each path has at most 1 band. Thus, this is a B1 EPG representation. And in letter B, we have a set of paths where each path has at most 0 bands. Therefore, this is a B0 EPG representation. Therefore, the graph C3 is a B0 EPG graph because there is a B0 EPG representation for this graph. The Helly property. The Helly property is a famous mathematics property that is defined as a set collection C satisfies the Helly property when each subcollection of C that is pairwise intersecting has a common element. It's possible to find examples of applications in several areas of science, such as code theory, semantics, computational biology, database, image processing, among others. This reference is Dorado et al. 2009. For the graph and representations, then the previous slide, we have the following. For the graph C3, in letter D, we have a set of three paths that are pairwise intersecting but no have a common edge among these paths. Thus, this representation is not a Helly representation. In letter C, the same occurs. Besides, the set of paths are pairwise intersecting is not a common edge among these paths. In other hand, in letter B, we have a set of paths that there is a common edge among these paths. Therefore, this is a Helly-B1-EPG representation for the graph C3. Okay, Helly-B1-EPG graphs were studied in Bornstein et al. In particular, Bornstein have studied characteristics of complexity and recognition for Helly-B1-EPG graphs. In other words, Golumbix et al. 2009 have studied B1-EPG representations, and this defined that each click in a graph in a B1-EPG representation can be edge click or claw click. For the graph C3, for instance, that is a click, we have an edge representation in letter B, and a claw click is a not Helly representation. Notice that when have a Helly-B1-EPG representation, so each click of this representation is represented by edge click and not by claw click. Exploring subclasses of Helly-B1-EPG, the next theorem say the following. Let G be a B1-EPG graph if G is S3, S3 line, S3 2 line, and C4 free, then G is a Helly-B1-EPG graph. Well, the demonstration is as follows. Suppose that there is a B1-EPG graph that is not a Helly-B1-EPG graph. So, if this occurs, then there exists one click of this representation that is represented by claw click and not by edge click. So, give me this representation, and in particular, give me this click, this claw click. In letter A, if in this claw click there are the set of paths PV, PV line, PU, and PT, because that PT there is not exists, we can delete the vertical intersection among PV and PV line and make this intersection with a horizontal intersection. This way, we transform this claw click in a edge click. So, in this representation, dashed paths correspond to optional intersection. Intersection can be occur or can be not occur. The same occur in this induced subgraph. Dashed edges correspond to optional edges that can be occur between two vertices. Well, of this intersection model, of this intersection EPG, B1-EPG intersection, B1-EPG representation, we can recover this induced subgraph by paths, and this induced subgraph, we can recover these four graphs. And these four graphs define a Helly-B1-EPG subfamily. Notice that any bull-free graph is S3, S3 line, S3 2 line. So our previous results implies in lemma 5 of Bernard-Rees 2009. In particular, Bernard-Rees 2009 define a Helly-B1-EPG subfamily that is defined exactly by bull-free graphs. This finishes the previous theorem. And in next theorem, we say the following. If G is a B1-EPG and diamond-free graph, then G is a Helly-B1-EPG graph. We need back to here. Well, that the demonstration is that G is a B1-EPG graph that is not a Helly-B1-EPG graph, so then there exists a claw on click, and there exists the claw is this form, and this claw is formed by at least 3 paths, and there exists a dirty path that intersecting exactly 2 paths of this claw. This form a diamond. For instance, the paths PV, PV line, PU, and PT that correspond to vertices V, V line, U, and T. These 4 vertices form a diamond. These 4 vertices form another diamond. And these 4 vertices form another diamond. So, in other words, graphs that are B1-EPG and diamond free not have structure to be non-Helly B1-EPG graphs. The following corollaries have as consequence the identification of several graph classes where the existence of a B1-EPG representation ensure the existence of a Helly B1-EPG representation. Okay, if G is a bipartite B1-EPG graph, then G is a Helly B1-EPG graph. Block, cactus, and line of bipartite graphs are Helly B1-EPG graphs. Well, by literature, we know that block, cactus, and line of bipartite graphs are B1-EPG graphs. And by literature, we know that block, cactus, and line of bipartite graphs are diamond-free graphs. Our previous theorem say that the graph, if a graph is B1-EPG and diamond-free, then G is Helly B1-EPG graph. Then block, cactus, and line of bipartite graphs are Helly B1-EPG graphs. This diagram depicts the classes of graphs that has been studied in this work. In particular, I'm have attention for this blue class that correspond to bipartite graphs. Notice that any bipartite graph is a Helly graph because bipartite graphs are triangle-free graphs. But in particular, for B1-EPG graphs, every B1-EPG bipartite graph is Helly B1-EPG. But there is bipartite graphs that not belongs to B1-EPG and not belongs to Helly B1-EPG. That is localized in this area. Future works. We want to study the relationship among B1-EPG, VPT, and EPT classes. We want to explore the Helly-EPG classes, and we want to characterize particular Helly subclasses that belongs to Helly B1-EPG, Helly B2-EPG, and Helly BK-EPG. By literature, we know that B0-EPG coincides with Helly B0-EPG. In particular, these classes corresponds to interval graphs. But the same is not occur for the another classes in this hierarchy. For instance, Helly B1-EPG graphs are properly contained in B1-EPG. Helly B2-EPG graphs are properly contained in B2-EPG graphs. And Helly BK-EPG graphs are properly contained in BK-EPG graphs? Well, here arises a question. What the set of graphs define the Helly hierarchy here? What the set of graphs define Helly-B1-EPG graphs? What the set of graphs define the Helly-B2-EPG graphs? In particular, what the set of graphs define Helly-BK-EPG graphs? This is an interesting future research. So this is our reference. Thanks for your attention. Thanks for what this presentation today, and see you late in next presentations. Bye bye.